So we all know in Prim's algorithm the input is going to be a graph. For that graph we are going to find out the minimum spanning tree. So there is a difference between graph and tree. I will let you know what is the difference between graph and tree. So graph, it consists of cycles. Here the graph is, you can see it is a weighted, connected, undirected graph. Weighted means edges are having weight values. Connected, yes, all the vertices are connected. And undirected graph, there are no edges between two vertices. So it is a weighted, connected, undirected graph. For this graph we have to find out the minimum spanning tree. So that is the problem we are going to discuss today. For that we are going to use this Prim's algorithm. What is a spanning tree? So a spanning tree is called as an acyclic subgraph. So without cycles we are going to construct, that is the difference between a tree and this graph. So graph tree we can call it as an acyclic subgraph. So we are going to construct an acyclic subgraph that weight values should be, if we sum up all the weight values, it has to be minimum. For example, for this one graph we can have n number of spanning trees are possible. Like we can draw so this is one possible spanning tree. Likewise we can have so this is another spanning tree. If we sum up these weight values, so here the total value is going to be 7 and for this the total value it is going to be 6. So minimum value is 6. But it is difficult to try out all the possibilities. If you are going to try out all the possibilities means it comes under brute force technique. So only we are going to use this greedy algorithm technique to find the minimum spanning tree by using Prim's algorithm. So hope you understand the difference between graph and minimum spanning tree. Graph where all the vertices are connected. Here the spanning tree, it is an acyclic subgraph, and when all the vertices are connected, if we sum up the values, it should be minimum value. For a graph there are n number of spanning trees are possible. So for our example we are going to consider this is the graph. It is a weighted, connected, undirected graph. So how we are going to solve this problem means, okay. So here we are going to consider a table, construct a table. From the table we are going to find out the minimum spanning tree. So for each, here you can see we are having 6 different vertices. For each vertex we are going to give 2 labels. So the labels are so name of the nearest vertex and the distance value. Likewise we are going to find out for each vertex. Here A is going to be the starting vertex. So that is my initial vertex A, and for these are going to be the remaining vertices. So for the starting vertex both these labels are going to be we are going to mark with a hyphen value. So A is my source vertex, the name of the nearest vertex is going to be hyphen. Likewise the distance is also going to be hyphen because that is going to be my initial vertex. For all the remaining vertices we have to find out these values, and I am going to write it in chronological order to avoid confusion. So chronological order means alphabetical order. From A we are having 3 different adjacent nodes, B, F and here there is a mistake, it is E. Okay. So there are 3 different adjacent vertices, B, F and E. So these are all the adjacent vertices to A. So writing from B, A is the adjacent vertex, the distance value from A to B it is 3. So I am writing the distance value as B of A comma 3. So from A, from B, for B, A is the adjacent vertex and the distance value from A to B is 3. Likewise for C, there is no vertex from A to C. So I am marking with hyphen comma infinity. Infinity means if there is a no edge between these 2 vertices. Likewise the next vertex is D. For D also from A there is no edge. So I am marking with hyphen comma infinity. and for F there is an edge. So from A the distance is 5. So f of there is a edge between A and F and the distance value is 5. Likewise for E the distance value is 6. So initially we have to start with a single vertex. A is going to be my source vertex. So I am marking both the values as hyphen, and for the remaining vertices I am writing it in chronological order to avoid confusion. If there is an edge or between these two vertices, that is from A, we are going to write the nearest vertex as A and the distance from that particular vertex to the starting vertex. So for the next iteration, so we have to select the vertex with the minimum value. Here we are having 3 different vertices with values, that is B, the distance value is 3, and for F it is 5, and for E it is 6. So the nearest value it is going to be B of A comma 3. So from A to B the distance value is 3. So we are going to connect the edges. So here you can see from A to B the distance value. So that is from A to B the distance value is 3. So next, now we are going to repeat the process with B as the current vertex. So from B we have to identify which are all the adjacent vertices. So for B, C and F, these two are all the adjacent vertices. So first I am going to check with C. Initially from A to C we do not have any edge, so it is infinity, but now from B to C we are having the value. So B is my nearest vertex and the distance value is 1. Likewise for D we are checking from B to C there is no edge, so we are continuing with the same previous value hyphen comma infinity. And for F, now you can see in the previous step for F, from A to F it is 5, but from B now you can see the distance value is 4. So we have to make a comparison which one is minimum, we have to take the minimum value. So here it is going to be B comma 4. So here you can see the difference. In the previous step F can be reached from both A and B. If I come through A the distance value is 5, but if I come through B the distance value is 4. Then for E the same, but we do not have an edge from B to E, so I am repeating with the previous value. So E of A comma 6. So this is the step completed if we have B as my next vertex. So I have to take my next tree vertex. So we have to select which value is having the minimum, which vertex is having the minimum value. Here we can see C is having a minimum value of 1. So my next tree vertex it is going to be C of B comma 1. So we have to connect the vertex B to C where the distance value is 1. Okay. Now we are going to repeat again from C. We are going to repeat with the process from C. We are having 3 adjacent vertices. Already B and F visited. So we are going to compare with D alone. So here you can see for D up to now we do not have a direct edge from A and B, but from C we have an edge. So for D it is going to be C of C comma 6. From D, for D we having an edge from C. So C and the weight value is 6, and the remaining vertices for F from C is also the weight value is 4. From B also we are having the weight value 4. So we are continuing with the previous value B comma 4, and the last vertex is E. We do not have an edge from C to E. So we are continuing with the previous vertex value. Here you can see the minimum weight value is 4, that is from B to F. So we are having that that is going to be my next tree vertex. and we have to connect those vertices B comma F. That is going to be my next vertex. So from F we have to check for the remaining two vertices D and E. Now you can see for D already we came from C, but the weight value is 6. But now from F it is 5. F is my vertex. So from F if I go to D, the weight value is 5. Likewise for E, initially we came from A, the value is 6, but if I go from F, the value is 2. Okay. So that is going to be the next vertices, remaining vertices. From this 2 is going to be the next value. So the next tree vertex, here I am writing. So the next tree vertex, it is going to be E of F comma 2. Okay. So only the remaining vertex we are not visited is D. So we are going to compare for D. If we come through F, it is 5, but if we go through E, the weight value will be 8. So we are sticking with the previous value D of F comma 5. So this is going to be the last edge. So here we are going to connect with 5. So this is the spanning tree for this given input graph. Then we have to calculate the minimum spanning tree. That is, we have to sum up the weight values of all the edges. That is 3 plus 1 plus 4 plus 2 plus 5. We have to sum up all the edges weight values. So the total value is going to be 4, 8, 10 and 15. So this is going to be the minimum spanning tree for this given input graph. Even if we construct the n number of possible spanning trees, we cannot get a minimum value less than 15 for this given input graph. So likewise we will discuss another algorithm in the next session. Thank you.